Well, thank you everybody for joining today's ELISA seminar, Meet the New KernelCI. We're very delighted to have Gustavo Padovan and Dan Zikas joining us as speakers to give us an overview of the new KernelCI and explore collaboration opportunities between the KernelCI project and the ELISA project and community. With that, I'm going to pass the microphone to the speakers.
Excellent. Hello, everybody. My name is Dan Zikas. I'm a distinguished engineer from Red Hat here, and I'm joining me today is Gustavo Padovan, a kernel lead from Collabra, and today we're going to talk about the new KernelCI. This is a Linux Foundation project, and we wanted to share with everyone on the call about what it is and what it's about. And hopefully we can draw some connections about what we do with what the ELISA project's looking to accomplish, and we can find a way to benefit each other. So our agenda is pretty small. It's about, I'm going to talk about what KernelCI is, what the project's about, who our audience is. We're going to talk about what we're going to do for the architecture, how we're trying to implement this thing, and we're going to do some interacting with the KernelCI, some call to actions, and hopefully Gustavo might have a little demo for us that works out. So pretty straightforward. Let's see. Okay, so as I said earlier, we are a Linux Foundation project that's been around for almost 5 years. We were started by a number of companies who had a common interest in stabilizing the upstream kernel to make it easier for downstream consumption. So we created a mission that reflected exactly that, ensuring the quality, stability, and long-term maintenance of a Linux kernel. Our goal was to put together an architecture that pulled in various pieces of the testing puzzle to create a solution or service to the community to help satisfy that mission statement. As you'll see later, it's a complicated architecture, but we have made good strides towards getting there. And Gustavo will talk about all that work. And we're excited to share where we are and where we are with it. So who's helping us on our journey? Well, this is the member companies that we have here. Most of these companies have been with us the entire journey. Collabra and Red Hat and Google and Microsoft and Civil Infrastructure Platform are our premier customers, and they've been helping contribute resources and knowledge and experience towards everything we do. Texas Instrument is a new member we've recently recruited this year, and they've been excited to join us on this journey and contribute their expertise, knowledge, and hardware and stuff. And Bay Libra is our general member, but they've been around since the beginning of I guess when KernelCI was in its infancy. So they've been amazing leaders there, helping us on this in our direction. So thank you to all those member companies that have helped us grow. So what are our goals? So we are focused obviously over on overall kernel quality and stability, but we're also trying to act as an umbrella project for the various pieces that we need to pull together here. And as you'll see later, the architecture it's complicated, but there's a lot of pieces of this puzzle. And as we try to pull things in, we've aligned with various working groups. And because we're a funded Linux Foundation project, we have funding which allows us to spend on needs to accomplish our goals. Those needs could be key software technologies we need to invest in, hiring or continue to pay people for side projects, to continue little projects that help put together pieces of information or drive, I don't know, different data projects that help with our effort here, that align with our goals. So we've been doing a lot of work there. And on top of that, we do have a lot of resources. We do have services here, and managing that and consolidating that down has been one of our goals this year, is to focus on the infrastructure, simplify it. And then just focused on putting together a testing team that allows us to put together a cohesive story around how we integrate tests. That's been something that collaborators kicked off, and it's been working well. So we've been focusing on these type of goals this year, really, to keep us focused and achieve great things. So what's our strategy? How are we going to achieve all these goals? What's the overarching direction we're going to march in? And it's really the shift left approach. I think a lot of this is a common industry term, at least I've heard it a lot, is the idea is to start testing as soon as you can before you merge the code, shift it to the left of the pipeline. So our goal, our effort really is to work with kernel maintainers as soon as they get changes into their trees or branches, however they collect the patches, and get it tested as early as possible. And expose it through our efforts of various CI systems, which plug into various hardware, to get as much feedback and code coverage as possible to them. So that when they go to push the code upstream to Linus's tree, it's as stable as it can be. So that way, when we pump it out to the Linux stable branch later on, it's already in a stable condition, and it needs far less patches to stabilize itself. Thus, when the downstream folks integrate it, it's in a better spot. So the hope is that we can flush out all the regressions earlier on. Less regressions we find helps us reduce this amount of patches we see in Linux stable, which achieves our overall goal. We speed up the stabilization of the downstream product industry. There's so much churn going on with the downstream products. We're trying to stabilize things. Let's cut out the low-hanging fruit and get them to focus on more of the challenging problems. So let's get the downstream people. We need to focus on less bugs. So we're hoping that all this stuff stabilizes. And also by shifting left, we're going to try to convince the entire CI, I guess the CI ecosystem or the upstream community to really focus on this. Is to march behind this idea and move forward with us. And that march is going to be challenging. So we're calling it a cultural shift. Not every maintainer or developer is on board with the idea. They've been doing the same way for 20 years. So how do you get them to change behavior? Is really just you got to change how they think. Show that there's value in what we do. Show that there's value in testing early and trying to improve tests, and kind of open up things and kind of collaborate more on this idea. There's a lot of companies out there that we're also going to focus on that have downstream consumers of the upstream kernel, and their testing is behind closed doors. So how do we open that up, get them to participate, put the hardware into the ecosystem, and really kind of open everything up and get everyone to contribute as a community towards this effort. So there's a cultural shift on some of the upstream developers, the upstream maintainers to accept CI. There's a cultural shift on how downstream consumers who tests it and have hardware and stuff, how to get them to open up and participate. And trying to get more developers to engage on higher quality tests. So there's a lot to do there. So who are we focusing on our audience? There's a lot to our architecture, but are really the people who are customers of this effort are really kind of four main groups. We have maintainers, upstream developers, hardware vendors, the product makers. And really what that means is that maintainers is our core audience member. Everything revolves around them. Our focus is to get them to use our services, our solutions as they collect the changes, they integrate it into they pass along these changes to our services, and we give them feedback so that they can make good decisions. You'll see a lot of our conversations revolve around how to keep the maintainers engaged, happy, and deriving value for them. But we have secondary audience members of that help with our system. Is we say upstream developers in this picture, but it's also about people who test and who I guess, can fix things or can react to the test results. Those are the people we need to engage. Say, hey, there's a CI failure, and triaging it is laborious. So get engaged, help improve the tests, the quality of the tests, so that we can focus. We can find the regression sooner, or we can get more detailed failures to help us identify the regression better. Hardware vendors, there's a lot of companies that have hardware labs. We want to give them the feedback. We want them to contribute their hardware. We want to test on their hardware. We want to give them the feedback, so they're providing value to all the downstream communities with their hardware, making sure that we find all their issues ahead of time. And product makers like the distros, giving them a more stable product downstream helps them a lot. It reduces their costs and allows them to focus on their customers' needs, as opposed to flushing out all the silly problems that we missed as Linus released out the door. So those are the people we're focusing as customers. So how do we do this? Well, this is where I hand it over to Gustavo, and he's going to talk about the architecture we have. Gustavo.
Okay. Hello, folks. This is the first time I'm speaking here. So that's a pretty complex diagram. It's our new testing architecture that we've been developing for the past year or so. Became pretty intense development during this year as we were finalizing many of those pieces. We will be showing today how this is working. We will also, from one end, we want to focus on how people as an audience, as Don was just saying, can benefit from this. But beyond the audience of kernel developers, maintainers, hardware vendors, people looking to test results in general, we are also enabling a test CI ecosystem. If you are familiar with the legacy KernelCI, you remember that we had a single CI system that was running some tests, sending that to essentially only embedded device at a time. And then we had some dashboards and email reports for people to see that. That was a very limited system. It wasn't allowing us to do much with that. We started facing many issues, but that's in the past now. We've been focusing on the new infrastructure. This is something that is that's deployed, that we've been fine-tuning, and we plan to have a full demonstration of everything that we achieved so far. There's many things that we'll keep developing over the months, over the years. There are many ideas, but the core of it is already there. So when we focus on a test CI ecosystem, we're not talking about having a system a CI system or service that's handling all the testing and then producing results and so on. We are talking about enabling many different services and bot and CI systems across the community to find ways to collaborate. So I think we want to focus on standards, on specifications, on common APIs, on common databases for making significant progress on how we are testing and validating the kernel. I think it's a pretty huge problem or challenge, that's a better word, that we have ahead on improving the test and validation of the kernel. We've been doing many things in the past few years, but I think we have a decade ahead, at least, of things we could do. So that's kind of the background idea for this testing architecture. And now I'll be diving in detail in some of those elements. We'll be looking to how people as kernel community can interact with this, but we also highlight how the test CI ecosystem can jump in and contribute their test results, or add their CI systems, or bring a lab, or contribute hardware to it, and so on. So before I dive into the next slide, you can see here, there's a little bit of a flow from community tools on the top left that you can inject results in. Maestro is a event generation orchestrator for generate the test jobs. Then we have like an ecosystem of CI systems that are part of the set of the data sources for KCIDB. And KCIDB is the common database, and then there is a web dashboard, and there'll be a demo. Hopefully, it will work of the new web dashboard. And we've been also creating this new tooling called KCI Dev for people to interact with KernelCI from the command line. Can we go to the next slide, Don? Okay, so the first step from a KernelCI user point of view is how you get like your test submission in. Today, as used to happen in the legacy KernelCI as well, you can have your trees as a kernel developer maintainer in KernelCI, and KernelCI will check that those trees like every hour or so for new updates and build your code. We have plans for adding GitLab CI support. We are halfway into the patchwork implementation, but we didn't find like the time and effort to finish it. But essentially, what I'm trying to say is that we are creating an interface where different tools can interact with the KernelCI infrastructure and can submit test requests. And those tools can grow over time, or people can implement their own based on the APIs that we expose. Beyond that, we've been, since a few weeks, developing this KCI Dev tooling for developers to request job retries. We are also experimenting with bisections on that. There is going to be other maintainer tools. It's a standalone tooling that we want to evolve over the coming months, but it has like the first few features are committed in the repository already, and it's part of like the day-to-day of some developers. So yeah, maintainers can register their branch. What else can I say here? Yeah, if you have a tree, you want to request it to be tested in KernelCI, you can, once we share the PDF of this presentation, you can click on this here link there and request your tree to be added there. Okay, next slide. Right. So once like test requests are sent in, we have Maestro as the first recipient of it. The main idea here is that we would love to have a common place for storing test specifications, trees that we want to build, and other related test information. And Maestro right now is fulfilling that place. Maybe things will evolve and we will change how that happens in the future, especially if we start like moving more and more of that information into mainline. But today, Maestro is a starting point that will be generating the test jobs based on the specs that are defined there. And it can create like events that anyone can subscribe to and listen to it, and then execute the test that the KernelCI KernelCI is creating, or Maestro is creating in this case. So it's the main idea is that we're developing a sort of like a message queue where people can just go and listen to all sorts of events from all the trees that we have like subscribed in there. It's optional, of course. Like I can have my own CI system here that will have like its own trees, its own test specs, and that's fine. You can be part of the ecosystem anyway. I think what Maestro is looking at is to have a common place where we can share all that information. We can have like a common HTTPS images for the test. We can have one single list of trees that we are testing, one single list of like tests that should be tested against certain trees or certain scenarios. And then people can throw requests into Maestro from their tools, like I said before, And then systems can listen to the events here and do whatever they want with the data they pull out of Maestro. Like they can use the images, they can generate their own test jobs for their own hardware, and then submit the data, the test results further down the pipeline. I guess that's the main idea here. We can move to the next slide. Then come the part where we actually need to run those tests, because Maestro is just like generating the events. It's not really running the test. There's a second stage in this software that will do that. That's like where KernelCI labs are implemented. But architecturally, we've been separating those two elements. Like one of the participants in that ecosystem, of course, our own labs in KernelCI. We have other systems like 0 Day, CKI, Sysbot, Microsoft. Other CI systems are looking to joining KernelCI and either just sending their data in or subscribing to the test events and artifacts that we're generating. So that's something that it's an ever-growing list of like CI systems. If you have a hardware lab or a CI system, or you've been running tests in a constant manner, you may want to add yours as well. And when we say add, that may mean that you would be contributing your data into our common database, which is going to be the next topic on next slide. So one of the core ideas of the KernelCI project, like we have a few, as a Linux Foundation project, we are acting as an umbrella and have like a few projects like KCIDB, Maestro. Other projects may join us in the future. So KCIDB is something that has been around for a few years. It aims at being like a central database for storing test results and allowing the community to rely on that for evaluating the test results, for building visualizations on top of that, for working on common ways of storing data. So KCIDB has a schema specification that every change that happens in the schema is a discussion in the community. You can see in the KernelCI mainly some of the recent discussions, like adding performance tracking in KCIDB, for example, or better specifying which platforms we are testing in KCIDB. And any CI system and test system can contribute their data there. So the power is really that we can have like one place where all the data can be stored, and then later you can choose which way you want to see that data. You can filter specifically for this source or that source, this tree or that tree. It's just like operating a CKL queries on the database, or using our dashboard and Grafana instances and so on. We've been developing post-processing issue identification, kind of like trying to make it like a powerful layer, because of the amount of data that we have daily. It's overwhelming. I guess for that, we can go to the next slide. So that's the analysis of the results, an area where we're putting a lot of focus right now. It's maybe the busiest part of the KernelCI project at the moment. We have a web dashboard under have development right now, like a truthful supplier that the KernelCI Linux Foundation project has contracted. I'll be doing a short demo of it. And beyond that, on the KCIDB layer, we've been trying to apply a few ideas and strategies to reduce the sometimes or oftentimes overwhelming amount of data and noise that maintainers and people trying to use KernelCI may get. Like from from using the legacy KernelCI, that was our experience. Like we couldn't really do much with the data because there was so much like flakiness or false positives, and we never invested into automatic analyzing that data. And then it gets to amount of like issues and false positives and flakiness that it's impossible for the human eyes to go through. So KCIDB has a concept like issues where you can start like logging a bunch of like different failures or incidents like to the same grouping them all together. And we've been trying to grow that like to like log parsing, to like matching different attributes or string matching and so on. And that process we are facilitating like the filtering of regressions and walking a path where we are going to become like better and better into exposing the regressions that matters to the community. So that's like I think the key value that we can provide with KCIDB is like it's not like only storing the data, but together with the visualization tools like the dashboard or email notifications, which are, by the way, highly configurable, we can really change shift the paradigm into looking into test data. Like I think today we have like a huge issue with like maintainer burnout. Like if KernelCI becomes able to help maintainers in that direction by showing them like more concise, precise information, give them like more clarity on what's going on their code, test results, and so on. I think that can be changing a lot of process across the community. Okay, I'll go for the demo now. Let me just like a screen share.
You want me to stop screen sharing for a second?
Oh, I think I'll take over in a way, right? If I try to do it. No, I can't. It's inactive for me. Maybe I'm not the presenter.
I paused my sharing. Does that free you
Okay,
up?
try it. Yeah.
We're still seeing your screen, Don, though. So I don't know if you've paused it properly. There we go.
I'll stop it.
Okay, I can. Yeah, I can bring it in now. I guess you can see this already.
Yes.
Yep.
Okay. So this is our under development web dashboard. It's nothing new here, like the list of trees. This is not really the production data. It's our like KCIDB has a playground data for us to evaluate the implementation of KCIDB, and then we have a production data, production database. This is still using the playground database, so some origins are missing data and so on. But I think we can share the main ideas here. So we have like the trees. We can go through like a tree, and it will load. It can show to us like the amount of builds we had, our success in this case. I don't think this tree had like history. Maybe I should go back and try a different tree. Let me try this Android tree. Okay, so here we have like a history. That's a recent feature that has been added like as of last week, I think. So we are still like under development. We are right now. You are able to see some interesting information about like all the things that are happening in the test runs, like the different configs. You can dive in, see details of it. Of course, like some things are still missing here. It's really under heavy development right now. We separate like the results into builds. Boots, because we think that that's a very important test case. So it's a separate one because no other test case will be running if a boot test case will run. I don't think this tree has a bunch of tests. Maybe this tree from Bruni has more. So here we can see some of the boot tests. Some information here is still wrong. We are fixing it, but I'm very happy that we have a dashboard and that we can show, that we can demo where we're going, and that we can get feedback on it. It's something that we've been working on for over a year now. We did the UX research. Some people were interviewed in the community to look at this. We got a lot of feedback, and now the implementation phase is moving at
The
an
origin
interesting
data is
speed.
there now, Gustavo. You can see the origin stuff too.
Sorry?
The origin data is repopulated again. So we have all the
okay. So yeah, we have different origins, and as we were showing, like the CI ecosystem, so you can see like data from 0 day. This is coming from the playground, so there is not much data, and there's data coming from the CKI system from Red Hat. There is data coming from Microsoft, so there is data coming from a few systems. Over time, we want to have ways to show all data from all origin at the same time. I think there's some technical limitations that prevent us to doing so easily right now, but we are moving that direction. Okay, I guess that's the demo. Maybe we can take questions later about that and stop sharing. Can we bring the slides back?
We can. Go. Is this where you want to start? You want to go to the next slide?
Could be the next one, yeah. The last thing to say here, if you look into the dashboard and have any feedback, we really want to hear it. Like right now is the phase where we can show enough data to solve the use case of like some maintainers, not all maintainers, not all use cases. And it's going to be the kernel community feedback that's going to help us to evolve the dashboard. That's the stage we are. So the feedback, it's highly important. We've been working with a few maintainers already, like solving needs they have in terms of like email reports, dashboards. There is also, I won't be showing it here, but there is also a Grafana-based dashboard where people can go and do any sort of queries into the database and build like dashboards with that. So some maintainers are using that. So we really want to see the community using it and also giving us feedback so we can improve on it. The KernelCI project is committed to keep improving this dashboard for the community to use. Okay, next one.
Okay, while we're waiting. Oh, you're going for, okay. Quick question then. How are the test specifications being encoded? And do you have effectively maintainer buy-in on them at the very start?
Yeah, we would love to have maintainer buy-in in all tests that we run. That's not the case today, but we are working on that, and that's exactly some of the content of this slide, like that we are trying to. So one thing that I think we failed in the past, even though we're running a bunch of tests and so on, is on the quality of the whole thing, right? The quality of the test itself, like it's well written, it's like or it's a flake test. Are the results like easy to manipulate, or is like overwhelming? People that can't really like make sense out of it. We got like feedback from Greg on the legacy system, for example. Look, I can't really use much of your data because there's a lot of flakiness in it. Like, okay, so now we have to go into the new KernelCI and work from that foundation. Can we before we increase or scale too much, can we make sure that we are setting a process for the quality of the whole system? And for me, there's two main points there. One is on the sort of like input of the pipeline, which is the tests themselves and the way that we decide to run the test. And the other side is how we evaluate the results. I just spoke about all the strategies for post-processing the data, automatically matching things, like automatically identifying flakiness and so on. And so that's done on this presentation. For the tests themselves, we've been since a few months running a testing quality working group, because we know how much we suffered over the years with the quality of the tests. So we've been focusing on developing like better tests. Until now, like most of the tests were like on the embedded side of things, but we've been stepping to other case self-tests and so on. So there is a focus on, of course, on the coverage, like the speed, the maintainability, the reliability of the tests. And we are strongly advocating to send those tests upstream. So they live in the mainline tree, the maintainer will have to go and review and act.
Right.
So we believe that in that process, the maintainer will be part of it. And slowly over time, we can change the mindset. Like it's a culture shift that we need. That's what Don was saying like in the beginning. And
Can I add a couple things to help with Kate?
Yep.
I have a couple ideas of where Kate's going to go with this question, but the idea is to work with the maintainers to make sure we're all on the same page about the accuracy of the test we're trying to define for this subsystem. So everybody's aware of it and we can contribute in the same direction. And I'm going to guess that's what ELISA needs, is because they want to have code coverage. They want to have documented test cases for all their subsystems. And we need to make sure we have a good collaborative process there that is reliable.
And we also want to make sure that we have our requirements for the code and then the test proving out to the requirements and have that full traceability there. So if we can get all these things linked together, then I think we are on a better path for keeping things stable.
Yeah.
Yeah,
I think the requirements and specifications, I think would be a step on top of this. Like right now, we are able to get the maintainer to act or sign off like a patch, a test that we add to mainline. Maybe like in a year, we'll be able to have in mainline somewhere we can start like specifying which things we should be running for each file or each part of the kernel. Like Nikolai, I think is here. He tried like to submit a test catalog idea where we would go to the maintainer's file and add like specific entries. That's a discussion that's pending. I think we need to have it like very soon in the community on how we start like logging, hopefully inside the mainline tree, how we test like each part of the kernel. But we are not tackling that yet. That's like KernelCI we have like our own specs, which is like YAML files in there, but we didn't really put like the raw thought on how to do it. Maybe that's where we start like shedding more and understand how Release is doing it, because you folks are thinking a lot on that.
We're thinking a lot on that and trying to figure out how we can actually get these pieces to connect together. Because we need all of them at this end of the day, and we all need it to be upstream in the kernel. So there will be a mini conf on Friday afternoon, and hopefully you guys can participate in it as well, so that we can see if we can identify where does the kernel community want us to be storing these requirements. So if people start to do the work to reverse engineer and actually understand what's happening with code and document it and getting the maintainer sign off, where do we actually keep it? And that might be something that's hopefully useful for us to then start connecting the testing to as well, when the tests prove out some of these requirements. So that's the piece we're sort of trying to figure out how we can get this. As you say, it's a cultural shift and it's a social engineering challenge more than anything else at this point. So I think we're both on that culture shift journey together for multiple reasons here.
So one of the things that Greg keeps pounding is that he wants the test to be either LTP or kernel self-test. That way it keeps everything focused there. Now, Gustavo, in my experience, you see the maintainers all have their own tests also outside that bubble. But if we can start running everybody in there, then you can start to say if everything's in K-self-test or LTP, you start to have a foundation for where you can store requirements, because those are already in well-known Git trees.
Yeah, no, I think that'd be good. I think there's also, like say, you've got a few other systems, the Lava system, Fuego, and so forth. I guess I'm just wondering how much of the embedded stuff has actually been integrated in to these systems right now. And
so Lava is a backend to us, so we have a few labs that are Lava connected to KernelCI right now. And other systems, they can either connect into KernelCI as a lab or send their data directly into KCIDB. There is a few ways that we can do it.
Okay.
All right, should we move to the next slide?
Yeah, thanks.
Is this the slide you want, Gustavo?
Yes. So one thing, like I was describing the KCIDB web dashboard, and it's really like we are launching a new infrastructure for KernelCI. We have like a bunch of user cases in there, a few maintainers using it, but it's really the beginning of it. And we don't support, there are many things we support and many other things we don't support yet. And we want to work with the kernel community. So we've been actively engaged with a few maintainers to understand the requirements, to go through like in detail on the dashboard. Oh, I want to see this data, that data, or I want to test like this thing or that thing. So we want like to have feedback, like what are the requirements from you as a kernel developer, maintainer, or a hardware vendor, or a product maker, any use you make of the Linux kernel. We want to understand like what kind of requirements we have in terms of like testing and CI integration for that. Like how do you want to see the results? How we should be customizing the dashboard for you, or email notifications, which tests or which areas, like in terms of trees, platform, and SOC families, so we can keep that in mind as we go through like the development of KernelCI. Like please send us email to our main list. Okay, next one. So that's our ambassador. Greg has been a big supporter of KernelCI over the years, and he will also love you to join KernelCI. And next slide. Yes, just like a final call to action. Yeah, if you want to benefit from this, if you want to have like your tree tested, if you want to engage more on this KernelCI ecosystem, please get in touch. We have community meetings, which are not like that friendly for some US time zones right now, but we have the main list. We have our C channel, and we're trying to sort out if which chat system we'll be using. There's been a few discussions internally, but we didn't settle anything new. Yeah, I guess that's that. Now I guess we turn into questions and comments and discussions.
There's been a couple of questions. I think Nikolai answered one of them, and another question disappeared. It's about external CI.
Oh yeah, oh yeah, Nikolai answered. Yeah, you can see the testing quality call reports in the main list. That's something you can interact with there. And just by being the main list, you'll see like some of the paths that are flowing to the kernel, to like new tests and some that we've been working on.
There's a question I think Nikolai also answered. I'm going to read the question and the answer for clarity here. The question was from Igor. What is your view on contributed CI systems added capacity? Special hardware target platforms. Is an external CI system supposed to provide workers for infrastructure? I believe this was Nikolai's answer. You can engage and integrate at the level of your choice, from sending test results to KCIDB, to connecting your hardware lab for running tests, for instance, through Lava, and different options in between. Is there anything we want to add to that answer?
No, not right now.
I mean, like as Nikolai said, we allow plugins. If you want to bring your own CI system, if you want to bring your own private systems and submit results, we're allowing that. It's a collaborative community effort. So hopefully that answers that question.
I didn't see this question, by the way, like some things are showing to me.
It got answered. It's in the answered tab. You go open QA and you hit answered.
Oh, there's a QA thing. Okay, anyway, I think Gabriele has raised his hand.
Yes, thank you, Gustavo. So I think I mean, it's interesting to see that this is an official project from the Linux Foundation, where many companies take part, and indeed, I am directly involved in the ELISA project. So, and indeed, a common goal between ELISA and also this KernelCI is probably to increase the quality of the kernel in your case through testing. So till now, I think we don't have a very close collaboration between ELISA and KernelCI, strictly speaking, in terms of working group. However, I was wondering that also going back to what Kate was suggesting, right? So because the Linux Plumber will have I think one or two sessions also presenting how an idea for tracing specification to LTP test, and also I think we may explore in general topics for collaborating and and evaluate how where we can improve the quality of the kernel, how we can assess and improve the quality of the kernel. So I think, I don't know, so to some extent, maybe we can in general we may start discussing if it's viable, few topics to collaborate more closely.
Yeah, for sure. Like, it's pretty clear to me that we have a very interesting overlap on how we specify the tests we need to run, like the test requirements and so on. There's people from the KernelCI community who are really interested into driving tests based on requirements. That's a topic that we didn't really start like work on it, or we didn't really had any deep discussions on the KernelCI side. And in fact, they were pointing at ELISA as a partner in this process, because we need to solve this together with the community. Like, I don't think KernelCI will come up with a spec and the people use it. We have to get this through like the kernel community and see what we can do essentially. Oh yeah, plumbers. Yeah. I think. Go ahead now.
Yeah, I think it'd be. I think we'd have a wonderful conversation if we'll be at plumbers. Let's meet up. Let's continue to engage. I think there's a lot of opportunity here.
Yeah, like we also have a bunch of activity at plumbers. In fact, I think our talk and Elisa's talk are one after the other, like in the agenda in the main track. We'll be pretty busy in the testing micro conference on Friday morning. Then Friday afternoon is the safety Linux one. We'll be there too. And yeah, I think we need to start like diving into those different like intersections that we are seeing right now.
Yeah, definitely. I mean, let's talk about plumbers, and we can directly we can talk about the current initiatives in ELISA, and and how we can intersect with.
Mm-hmm. Yeah, because it's not only like the test requirements themselves, but how the data gets to shown to be displayed in the dashboard. Like we never thought of that side. Like we are showing the test results and so on, but maybe there's like much better ways of showing things by requirements or by covers and so on in the dashboard, and we need to also uncover that.
We have an open question. From Matthew Weber, has Yocto integrated CI results with KernelCI? I believe our answer is no.
Yeah, not yet. We are happy to, but we didn't have any chats with Yocto so far.
Well, I think there'll be a lot of the Octave folk. There'll be some of the Octave folk anyhow at plumbers as well, working on the build. The open embedded more than possibly than the Octo, but yes. So I think we have some potential there to start seeing if we can get some overlap going. And certainly we can.
I'd like to think that Nikolai reached out to the Yocto folks a few times. He's been trying to grow the KCIDB submission pool for the last couple of years.
Okay.
Are you allowing external parties to populate your build artifact directory?
Are we allowing external parties to populate our database? I believe so.
Maestro, the build artifact. So like the
Yeah,
obvious thing for Yocto.
Yes, you can do that. Yeah, but then you go and implement that inside Maestro. Like we have other user space there. Like we have like a few base rootfs, like I guess based on Debian, but there is also ChromeOS user space. For example, I guess they would be bringing some Yocto builds there to test with the new kernels that are arriving. But apart from that, they could also have their own system and just like send the results in. They don't need to interact with Maestro if they don't want to.
Nikolai, you want to add to that?
Yeah, first of all, regarding Yocto, we only had like minimal contact with Yocto, and there was no attempt to bring them in so far. Like there was some early contact, but not more than that. I would be happy to work with that. Regarding the build artifacts, Tim, do you mean publishing the builds so that somebody can run tests on them?
Well, yeah, like root file system, Yocto root file systems, that type of thing.
Yeah, that's the Maestro thing. Yeah.
Well, in principle, even if you don't integrate with Maestro, KCIDB has the support for specifying all the files that you want as part of your result, and we are working on the caching system that will download those artifacts, and there will be available on KCIDB on the dashboard.
Or I assume at least links to artifacts, right?
Sorry?
Or are you actually storing rootfs's in KCIDB, or are you storing links to rootfs's?
Right. So this depends on the size. We'll have to decide on policy. Right now, we're like in the experimental stage there with the archive. So we'll have to decide on policy how big it is, how long we're going to store it, etc., and describe it to the users like as a level of service.
Okay.
But we are thinking about that. Like the main purpose of the artifact archive is to be able to triage the results and retriage them as the issue descriptions change. So it's mainly about logs, but the builds and the rootfs need to be stored somewhere as well at a certain level of how long we're going to store them and
right
how big.
Yeah, well, so the aerospace working group, right, is looking at a Yocto-based distribution, so that's why it's salient.
We've got a question in the chat from Rob Woolley. If you guys, basically, he's just asking, are there any getting started instructions for the infrastructure setup or to locally kick the tires?
Oh yeah, if you go to docs, docs.kernelci.org, we have some instructions there on how to get started on things. And you can also ping us on RC, and people will gladly help you there.
I'm assuming the infrastructure you're looking at, Rob, is like a Maestro instance, like a test harness that runs test jobs on hardware you provide.
Yeah, my initial thought was if I don't want to populate the database with junk data while I'm experimenting, I just want to have a local copy so I could experiment without interfering with what other people are doing.
Yeah, I think anyone can run the test. You need to usually have a separate service that pumps the data from your results into the KCIDB. So I think the risk is low from accidentally populating KCIDB.
KCIDB has also Playground, which is, well, not production, so people can play with it.
Yeah, it's specifically set up to allow you to, go at it and, try things out, send data, take a look how it looks on the dashboard, etc.
Well, there are no further questions. We're just about at the top of the hour. So I want to thank you again very much to Gustavo and Don for coming and doing this with us and giving us a bit of a tease for what we're going to be talking about at Plumbers, as well as giving us a chance to do our homework before Plumbers, which is appreciated. And
all right, thanks for the opportunity. Thanks for the invitation. Yeah, we are happy to do it.
Yeah, with that. And yeah, thanks everybody for joining today's ELISA webinar. We will get the slides and recording distributed to everyone who registered for the webinar. Also, we upload all of our past webinar videos onto our seminar series library. I just put the link in the chat. You can, when you have time, you can listen back to our previous webinar recordings there as well. Thanks again, and thank you to the speakers, and we'll talk again. Bye.
Thanks for having us.
yeah, bye.
Bye-bye. Thank you.